In today's lecture, we will be looking at two sections from Chapter 3, Probability Topics, 3.3, Two Basic Rules of Probability, and 3.5, Tree and Venn Diagrams. There are two basic rules of probability. The first is the multiplication rule. The multiplication rule says that if A and B are two events defined on a sample space, then the probability of A and B is equal to the probability of B multiplied by the probability of A given B. So note that PA vertical line B is read the probability of A given B. Now, since A and B are interchangeable, you could rewrite the multiplication rule either one of these ways. It means the same thing. Now, if A and B are independent, so one does not affect the other, then the probability of A given B is just the probability of A. So in that case, when you have two independent events and you want to find the probability of A and B happening, you simply multiply the probability of A and the probability of B together. The second basic rule of probability is the addition rule. If A and B are defined on a sample space, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now, this is so that if A and B have an overlap, that you would subtract that overlap so that you're not counting it twice. If A and B are mutually exclusive, though, that is, they cannot happen at the same time, then there would be no overlap. So the probability of A and B would be equal to 0, and thus the probability of A or B happening is simply the sum of the two individual probabilities. Question number 1 considers the use of the multiplication rule. So it says, consider two events, A and B, where probability of A is equal to 0.97 and probability of B given A is 0.09. So in this case, we're supposed to find the probability of A and B. So looking up at these two possible formulas up here, we see B given A represented in the second formula. So in that case, we would simply replace the probability of A with 0.97, replace the probability of B given A with 0.09, and when you multiply these two together, you get 0.0873, or approximately 0.09 for the sake of my open math. Question number 2. This is about D&D, and you don't have to know anything about D&D to do this problem. Let's say that only 40% of all D&D players play as orcs, so we would write that as probability of orc equals 0.4. Of those that do play orcs, 50% play as barbarian orcs. So that would be the probability of B given O, that would be 0.5. If you were going to pick a D&D player at random, what is the probability that they would play a barbarian orc? So barbarian orc means that this player is both barbarian and orc. This is a B and O. So that works out very well because we're looking at the multiplication rule. So we would write the probability of B and O is the probability of orc times the probability of barbarian given orc. So then 0.4 times 0.5 is 0.2. Question number 5. Suppose that 13% of people own dogs. If you pick two people at random, what is the probability that they both own a dog? Now, it's true that after you pick the first person, you don't put the first person back into the general population. But if the general population is really, really big, it's quite negligible whether you put that first person back into the general population or not. So in other words, picking one person and then picking the next person, that's going to be independent because you're dealing with a huge population and it's a negligible difference whether you're dealing with a replacement or not. So then you can just multiply the two individual probabilities together. We would say that drawing two separate people would be considered independent events. So you can let A be the event first person owns a dog, and B the event second person owns a dog, and now the probability of A and B is equal to the probability of A times the probability of B. That's just 0.13 times 0.13. That's 0.0169 or 1.69%. Oops. Yeah, so in terms of what is written on my Open Math, just follow whatever the directions would be required. In this case, though, notice that percentage is changed to decimal. So our final answer, 0.0169, represents 1.69%. Now for the addition rule, question number 9 has us look at 3 scenarios. PU and V, PU given V, PU or V. Now throughout this lecture series, I recommend as much as possible, pause the video so that you can make sure that you can try these out on your own. U and V are mutually exclusive events. All right? So if two events are mutually exclusive, that means that their intersection is 0. U and V then would have to be 0, right? Second question, U given V. So what is the relationship between mutually exclusive and given? The two cannot happen simultaneously. So that means that if you have V, you cannot also have U. And so they're both actually 0. And lastly, P, U, or V, the probability of U or V is the probability of U plus the probability of V, because they are mutually exclusive. So we simply add the two individual probabilities together. Question 10. Suppose a special 21-sided die is rolled once where each face is marked with the number 1 through 21. What is the probability that the die lands on a 15 or a 4? So we would want to note that we're rolling the die only once, and a die cannot land on both a 15 and a 4 at the same time. So these are mutually exclusive events. So the probability of 15 or 4 would simply be the probability of 15 plus the probability of 4, again, because they are mutually exclusive events. So 1 over 21 for each roll, simply add them together and you have 2 over 21. We will continue on with question number 7 in video 2.